A very good morning to you children. Algebra, another branch of mathematics, is introduced to you when you were in 6th standard. Algebra deals with solving problems using constant numbers and certain letters from the English alphabet as X, Y, Z, etc. and we call them as variables. They were called as variables because the values may change depending upon the questions. Here, chapter 2, Polynomials, comes under the branch of mathematics, algebra. Algebra is used when statements like 2 is added to a number or 3 is subtracted from the product of x and y or 8 is divided from a number. When you are given statements in these forms, you are translating those statements into expressions. You are translating the statements into expressions. The expressions with letters and number were called as algebraic expressions. Therefore, what are algebraic expression? Algebraic expression is a combination of numbers and letters. And how are these numbers and letters connected? They were connected by the 4 fundamental operations of maths as addition, subtraction, multiplication and division, and at the same time the numbers are belonging to real numbers. That is, any real number can take the place of the numbers. Thus, algebraic expression is a combination of numbers and letters connected by the 4 fundamental operations in maths, and the numbers are all real numbers. Thus, in 7th standard, you were learning how to operate, that is, how to add, subtract, multiply and divide various algebraic expressions, and the basic details of what are the terms of an expression, what is the degree of an expression, and so on. These are certain examples of algebraic expressions. Algebraic expressions. When you take the first algebraic expression, you can see that the variables involved are x and y. The second expression has variables x, y, z, x and z, p, q. Thus, all these expressions have the variables as well as the numbers, rational and irrational numbers. That is, all the numbers belong to the real number system. Now, let me explain to you the basic of these algebraic expressions. What are the terms of this expression? The terms of this expression are x plus 3y and minus 9. So, when you group them, it will become an expression. The terms have to be mentioned with the sign allotted to them. What are the terms of this expression? Are 8x square minus 3x cubed y and 6z. Here, root 3x cube comma minus 7 by 9 z square. And this expression is made up of p cubed minus q square and plus 6. The power of the variable x is 1. Power of the variable y is also 1. So, which is the maximum power here? The maximum power is 1, and so this expression is of degree 1. What about the second algebraic expression? The power of the variable x is 2, 3, and here it is 1. So, what is the total? It is 3 plus 1, 4, and the variable has the power 1. So, what is the maximum power of the variables is 4. Thus, the degree of this expression is 4. Similarly, 3 and 2, the degree is 3. 3, 2, and the degree. If you have a constant, how can you represent it with the variable is any variable with the power 0. So, what is the degree of a constant? The degree of a constant, you can take it as any variable with the power 0. But the maximum power is 3, and hence the degree is also 3. The degree of an expression is the maximum power of the variables involved. If there are more variables, you will add their powers to get the total, and the highest power will determine the degree of the algebraic expression. Take the examples of these expressions written here. What is the speciality you find? You find that all these expressions are made up of only single variable, or this expression is in variable x, this expression is in variable t, this is in p, and this is in variable q. How do we represent an expression in x? We can call it as p of x, or q of x, or r of t, or s of p, or p of q. This is the way of reading an expression. And now, what is a polynomial? So, how can we define the general form of a polynomial? An expression p of x is equal to a0 plus a1x plus a2x square plus etc. an x raised to n is a polynomial of degree n. Of degree n if what are the conditions? a0, a1, etc. are all real numbers, and the second condition is the power of x should be a non-negative integer. It should be a non-negative integer. Thus, an expression p of x is equal to a0 plus a1x plus a2x square plus etc. an x raised to n is a polynomial of degree n if a0, a1, etc. are real numbers and the power of x should be a non-negative integer. From 0 onwards, 0, 1, 2, 3 can be the powers, but negative integers cannot be the powers of the variable. And since the degree n is mentioned here, one more important condition is an term should not be 0. If an term is 0, the degree of the expression will be the previous one, n minus 1. Therefore, the third condition is an should not be equal to 0. a monomial. A polynomial with only one term is called a monomial. A polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial, and so on. Similarly, can we write some examples of polynomials and some examples of polynomials which are not? 2 or 3 examples. 3x square minus 5x plus 8. 7. It's a constant, but still it can be written as 7x raised to 0. Or the polynomials of the form 5 by 6 x raised to 7 plus 8. Or root 5 z cubed. These are all examples of polynomial. A polynomial of 3 terms, trinomial. This is a monomial, or this is a binomial. The examples are already here, and now 7 can be either a constant, but still it is a constant polynomial. You can call it as a constant polynomial. There's the examples of polynomials, as well as we could see the term-wise distribution, monomial, binomial, trinomial, and a constant polynomial. What are the cases when we cannot call them as a polynomial? Is the expressions of the type 2 by 3 square root x minus 8, or 5 by x square plus 6x. What can be the reason is, when you understand the radical symbol, how to convert it into power as square root x is the same as x raised to half. 1 by x square is the same as x raised to minus 2. Thus, because of the factors root x and 1 by x square, these two expressions are not polynomials. I hope you copied the notes in your notebook. Consider polynomials of the form 3x, 8x plus 6, root 5x minus 8, etc. What can you find here? You can see the degree of this polynomial is 1. What do you call these polynomials? If the degree of the polynomial, if the degree is 1, such polynomials are called linear polynomials. That is, a linear polynomial is a polynomial of degree 1. A polynomial of degree 2 is called a quadratic polynomial, and a polynomial of degree 3 is called a cubic polynomial. And your syllabus has only linear polynomial in the first and second exercises. So what is a linear polynomial? A polynomial of degree 1. A polynomial of degree 1 is called a linear polynomial. If you replace the numbers with letters A and B, what can be the general form of a linear polynomial? The general form of a linear polynomial is, by replacing the numbers with A and B, the general form of a linear polynomial is ax plus b. The general form always contains plus here, but when you write the terms, you can separate the terms with their sign. So the general form of a linear polynomial is ax plus b. Similarly, for your knowledge, what will be the general form? Ax square plus bx plus c. What will be the general form of a cubic polynomial? Ax cube bx square cx plus d. Thus, these are the different types of polynomials: linear polynomial, quadratic polynomial, cubic polynomial, and their general forms. The next topic is zero of a polynomial or zero of a linear polynomial. You are given a polynomial p of y is equal to 8y minus 3. There are two questions which can be asked with this topic. What is the value of this polynomial if y assumes different value? Or they can ask you, find p of 0, p of 1, p of minus 2, p of 6 and so on. How will you find out? You just substitute the value of that y as per the given value. P of 0 is equal to 8 into 0 minus 3. Answer is minus 3. P of 1, 8 into 1 minus 3, 8 minus 3, 5. P of minus 2 is the same as 8 into minus 2 minus 3, minus 16 minus 3 is minus 19. P of 6 is equal to 8 into 6 minus 3, 48 minus 3 is 45. This is the first type of question which can be asked. Find the value of the polynomial for particular values of the variable. The second type of question is, given p of x is equal to x plus 3. The question is, find the zero of this polynomial. What will be the meaning? The meaning is, what value of x you will substitute so that x plus 3 value has to become a 0. A 0 polynomial means the value of the polynomial should be 0. The answer what you were getting should be 0. So the question is, what value of x? What value of x will make x plus 3 a 0 polynomial? That is the meaning of 0 of a polynomial. Thus, x plus 3 equal to 0 gives you x is equal to minus 3. That is, if you substitute minus 3 plus 3, it is 0. Thus, the 0 of a polynomial is that value of the variable which makes the polynomial a 0 polynomial. The degree of a 0 polynomial is not defined. The degree of a constant is 0, but the degree of a 0 polynomial is not defined. By these explanations, I think children, you will be able to do exercise 2.1 as well as exercise 2.2. Just briefly, I will read the questions for you. First question, exercise 2.1. Which of the following expressions are polynomials in one variable and which are not? Write the reasons for the polynomials which are not. Question number 2, write the coefficient of x square. Question number 3, give an example each of a binomial of degree 35, monomial of degree 100. Write the degree of the following polynomials. Classify the polynomials as linear, quadratic and cubic. This is page 32, exercise 2.1. Page 34, exercise 2.2. First question, find the value of the polynomial at x equal to 0, x equal to minus 1, x equal to 2, the type 1 question which I explained. A similar question, find P of 0, P of 1, P of 2. Third question, verify whether the following are zeros. They have given a polynomial and a value. Substitute and check whether the answer coming is 0. If it's a 0, it's a 0 of the polynomial, or else it is not. Fourth question is, find the 0 of the polynomial in each of the following. You are given only linear polynomial, so just substitute the values. I think exercise 2.1 and 2.2 can be completed within 2 days.